Hello student, welcome to the fifth lecture of classical mechanics course. From last two lectures we discussed about the projectile motion in resistive media. So in the last two lectures we derived the equation of motion for a projectile along the horizontal axis as well as along the vertical axis. So in today's lecture, with the help of these two equations, equation along x-axis and equation along y-axis, so with the help of those two equations we are trying to find out the equation of path. So what is the equation of path, what could be the nature of that path, and from that nature what are the different information we can collect. Okay, so let's start our discussion by the last equation or before that. So we know the equation number 1.8. so equation number 1.x is x is equal to u cos theta upon k 1 minus e to the power minus kt. So this is equation number 8. So from that equation we try to figure out what are the information we can get from this equation. So restructure this equation. So kx is equal to u cos theta is equal to 1 minus e to the power minus kt. Let's say this is equation number 1.16. This is equation number 1.16. Okay, so again rewriting this equation, e to the power minus kt minus sign as it is equal to kx upon u cos theta. I just put this 1 into this side, so I'll get this minus 1. Okay, so if I just rewrite this, multiply both sides of the equation by minus 1, so you will get the e to the power minus kt is equal to 1 minus kx upon u cos theta. Okay, so I just multiply both sides of the equation by minus 1, so you will get this equation. Okay, so again take ln of both sides, taking ln of both sides, natural logarithm of both sides. So what do you get? Yes, if you take ln of e to the power minus kt, so what is the result? Minus kt as it is, because we know ln of e is again 1 is equal to ln of 1 minus kx upon u cos theta. Okay, so I just again some mathematical, I just move this minus k into this side, so I'll get minus k and remaining term as it is 1 minus kx upon u cos theta, so remaining term as it is. Okay, so this is the form of the equation. But look at the values of these equation, ln of 1 minus something or ln of 1 plus something. So we know the form of, yes, from basic mathematics, what is ln of 1 plus x? Do you remember? Yes, so this is x minus x square by 2 plus x cube by 3 minus so on, so alternative plus and minus sign. So if we compare this equation with our t equation for t, so we have instead of x we have a minus kx upon u cos theta. Instead of x we have minus kx. Keep in mind this is plus sign, we have minus sign. So if you convert these equation into this form, so we have to write ln of 1 plus of minus kx upon u cos theta. So instead of x we have a kx upon u cos theta. So instead of x we have a which value? Kx upon minus kx upon u cos theta, because if you put the minus instead of x, so you will get this form of the equation. Okay, so just rewrite this equation and the expansion of ln term. So 1 minus k as it is, and for ln of 1 minus kx, instead of x is equal to minus kx upon u cos theta, and put it into the expansion. So what is the x value? Minus kx upon u cos theta, minus sign as it is, and what is the square of this negative term? It again positive, so minus sign, keep it as it is. So k square x square upon u square cos square theta and into 2. Okay, so keep in mind these 2 as it is. So this is not square, this is a multiplication. Okay, plus x cube upon 3. So what is x? Minus kx upon u cos theta, and cube of this negative quantity, again it comes out to be negative. So instead of this plus, I just write this minus sign, and the k cube x cube upon 3 I just write before. So u cube cos cube theta and so on. So this is the continuous expansion. Okay, so I just multiply this 1 minus k into the whole equation. So what I get? So if I multiply this minus to this minus kx upon u cos theta, so k goes away, minus become plus. So what is the form of equation? X upon u cos theta, again minus plus, 1 upon k, 1k goes away, so kx square upon u square cos square theta, sorry 2 as it is, so this 2 I just write it here, again minus k, so 1k goes away, and minus plus k square x cube upon 3u cube cos cube theta. So this is the form of the equation if you just put this value in this term. So this is equation number 1.17. okay, so previous equation. So what is the form of equation? So this is equation number, let's say 1.16. okay, so we have a form of equation in terms of t with the known quantities u and theta, and we have a equation number 1.16. So resubstitute these value, equation number 17 and equation number 16 in equation number 15, which is the equation of y, equation along the vertical direction. So if you know the equation 16 and if you know the equation 70, we can easily calculate the value of motion of the particle or the path for the particle. So substitute equation 1.16 and 1.17, or so this is equation number 1.70, this is 1.80, so equation 1.16 and 1.18 in equation number 1.15. That is a equation of projectile along the vertical direction. So what is the form of this equation? So equation 15, so y is equal to g plus ku sin theta, g is equal to ku sin theta plus k square upon k square into 1 minus e to the power minus kt minus g upon k and to t. So g plus ku sin theta upon k square 1 minus e to the power minus kt minus g upon k into t. So this is equation number 15. So instead of these 1 minus e to the power minus kt, we have equation number 16, and instead of t we have equation number 18. So resubstitute those value in this equation, we will get y is equal to g plus ku sin theta as it is upon k square. So instead of 1 minus e to the power minus kt, we have kx upon u cos theta. So this is from equation number 16, and minus g upon k as it is, and instead of t we have a x upon u cos theta plus kx square upon 2 u square cos square theta plus k square x cube upon 3 u cube cos cube theta, and this continuous term. So okay, so expand this equation, so we will get the so separately multiply each and every term in this equation. What you get, y is equal to yes g upon this is k square, so g kx upon k square u cos theta plus ku sin theta and this k, so k square x k square x u sin theta upon k square u cos theta minus g upon k, so gx upon ku cos theta minus gkx square upon 2k u square cos square theta minus gk square x cube upon 3k u cube cos cube theta. Okay, so this is the complete expansion of this equation. So look at what are the values. Cancel out this k, 1k goes away, so this k square cancel out, this u again cancel out, again this 1k goes away, this 1k goes away. So what are the remaining terms? So y is equal to gx upon ku cos theta plus yes x sin theta upon cos theta. So x sin theta, or instead of x sin theta upon cos theta, so we just write x tan theta minus gx upon ku cos theta as it is, minus gx square upon 2 u square cos square theta, and minus last term gk x cube upon 3 u cube cos cube theta. So this is the complete expansion. Okay, so again look at those values. So these again coolly cancel out. So what are the remaining terms? So remaining terms are y is equal to x tan theta minus this goes away, so gx square upon 2u square cos square theta minus g kx cube 3 u cube cos cube theta. So this is y is equal to x tan theta minus gx square upon 2u square cos square theta minus gkx cube upon 3u square cos cube theta. So this is equation number 1.90, and this is the equation of path of the motion of the projectile in the resistive medium. So this is the equation of path for the projectile in resistive medium. So look at the values of y, look at the dependence of this path motion. So theta known quantity, u known quantity, and these k factors comes into the picture. So basically this K factor decides the resistivity of the medium. So when projectile move in the resistive media in the presence of air, so which affect the motion of the projectile, so the motion of the particle, motion of the projectile in the motion is depends on the K value. So when K is larger, so in that case Y value goes into decreasing order. So more be the K, low be the value of Y. And if you just look at the value of Y from height point of view, so maximum height reached by the projectile, so in that case when K factor is more dominating, so in that case maximum height reached by the projectile is again low. Okay, so this Y equation, so the standard equation of the projectile, that is this projectile path of the projectile is symmetrical divided into two parts. So this is the form of the projectile, so half part is symmetric to the other half part. But look at this equation. So this is not the equation for parabola. This is not the equation for any kind of the parabola, so it can be represented like this. So this is not the equation. So that's how these equation look like. So if for non-resistive media, that is K is equal to 0. So for non-resistive medium, K is equal to 0. If you put the value of this K is equal to 0 in this equation, we get the normal equation which we already talked about this in our T.Y.B.Sc or 12th standard. So instead of K, I just put the value 0. So I just get this x tan theta minus gx square upon 2u square cos square theta. So this is value K is equal to 0. So this is equation number, let's say 20, and this equation number 1.20 is the equation of path for the parabola in non-resistive medium. So if there is a no resistive media present, so in that case the equation of the path is y is equal to x tan theta minus gx square upon 2u square cos square theta. So look at these values. So you come up across such kinds of the equation, and this equation is the equation of parabola. So in that case you clearly distinguish the effect of resistive medium in the motion of the projectile. So if you compare equation 19 and equation 20, you will graphically look like this kind of the motion. So if there is a no resistive medium, so for K is equal to 0, according to equation 1.20, so motion of the projectile is look like this. So there is a symmetricity in between these motion. This half part is mirror image of this last half part. But if we have a resistive media and the equation of path is depend on the K value, so in that case motion of the projectile is look like this. Okay, so look at these two equations, these two projectile, these two path. So in that case you will find if resistive medium is absent, so the projectile motion or the path followed by the projectile is symmetric in order to if you look at this maximum height point of view. So half part is symmetric to the rest of the half part. But if we have a projectile motion in the resistive medium, equation 1.90, so in that case projectile motion of the projectile affected by the K values, and in that case with the same theta angle, with the same initial velocity, projectile follows these kinds of the projectile trajectory. So in that case height of the projectile again decreases with these factors. So this is just the qualitative representation. And the last part, this is this second part of this trajectory is not the symmetric to the first part of the trajectory. So that's how this projectile or the projectile motion is different when we look at these in presence of the resistive media. So this is the difference between these two values, equation 1.19 and equation 1.20. So with the help of these two equations, we can clearly see that how these resistive medium affect the motion of the projectile. Okay, So with the help of this 1.20, we again derive the equation for range, equation for height, maximum height, and of course equation for time of flight. So in the next lecture, with the help of equation 1.20, we derive the equation for range, equation for height, and time of flight of the projectile. So for today, we'll stop here. Thank you very much.